For this question, we have the function f of x equals 11 over x, and we're also told that it is a one-to-one function. We want to find the inverse of the function f, state the domain and range of f, state the domain and range of f inverse. So to find the inverse of f, I'm going to start by taking my function f of x equals 11 over x. And I like to do this in 3 steps. The first step is to change the notation of f of x to y. So we're going to write y equals 11 over x. The next thing that we're going to do is switch the x and y variables. So we'll write the equation x equals 11 over y. And then finally we're going to solve for y. Rewrite the equation so that we have y equals. Now this step right here is essential to creating the inverse. Inverses have the x's and y's switch, so by us switching the x and y in our equation, that's what creates the inverse. So I'm going to solve for y. We're going to solve for y by multiplying by y on both sides. So multiply by y on the left, multiply by y on the right. The y's cancel on the right, and we have 11 equals xy. And now I'll solve for y by dividing both sides by x, and we have x equals 11 over x. So the inverse of this function, the symbol that we use for inverse is f with a -1 in the superscript, is 11 over x. So this is quite interesting because the original function is 11 over x and the inverse is 11 over x. So we have a function that is the inverse of itself. Okay, if we're feeling a little bit iffy about that, we can verify. The way that we verify that two functions are inverses of each other is by doing the composition. So if we do the composition and we get x, then we have inverses of each other. So I'll substitute 11 over x into 11 over x. That would give 11 over 11 over x. This is the same thing as 11 divided by 11 over x. When we divide fractions, we multiply by the reciprocal, so that's 11 times x over 11. The 11s cancel, and we get x. Also, if we verify the other way, f inverse composed with f, we get the exact same calculation, giving us x. So these two functions are inverses of each other. Or stated more clearly, this function is an inverse of itself. So then we want to state the domain and range of each one of these functions. So f of x is equal to 11 over x. And because this is a rational function, we're looking for where the denominator is equal to 0. So the denominator will equal 0 when x is equal to 0. So we exclude that value from the domain. The domain of f is -infinity to 0, union with 0 to infinity. The domain of f inverse is the same function, 11 over x. So the domain of f inverse is -infinity to 0, union with 0 to infinity. And something I talked about earlier is that inverse functions switch the x and the y variables. Domain is the set of x values, range is the set of y values. So if we switch the x and y variables, we're also switching the domain and range. So the range of f is going to be the domain of f inverse, so negative infinity to 0, union with 0 to infinity. The range of f inverse is going to be the domain of f, negative infinity to 0, union with 0 to infinity. So we have this particular function, f of x equals 11 over x, has an inverse that is also 11 over x, and we have the domain and range of each function being all real numbers except for 0.